Okay, this is a video kind of halfway through Chapter 5 and how to properly solve polynomials. And in this lecture, you'll see various different ways to solve polynomials. And even for some problems, I'll show you several different methods per problem how to do it, i.e. taking the square root, factoring, or using synthetic division. So this kind of puts it all together. This kind of review. So just going off the one worksheet on solving we did together. Now the first couple of problems just kind of warm up. Just want to point out a couple of things here. Notice problem number 1, you take out a GCF of 2x first, and notice you have a difference of cubes. So then you go ahead and use the pattern highlighted here and here, the a cubed minus b cubed pattern. So you have to recognize that. Question 2, this is grouping. What the purpose of this is, we have 6 terms, and it just shows you that no matter what number of terms, as long as it's even, try to group to see if certain elements can pull out. Notice that once you pull out a GCF, 2a plus b plus c is common in both front and back, and we have the same answer down here below. Okay, so point out those two things there. This one here, write in standard form. Here I give you question 3 to factors. You just go ahead and distribute and multiply out, 2 factors at a time to get the final answer. Number 4, I give you the solutions. So take the solutions, write them as linear factors, as you see in red here, and then from there, go ahead and multiply them together until you get the standard form. Okay. So again, just how do we go from solutions to polynomials and factors in between? All right, now, just going through here, these are all the questions, and what we have here are all the answers from questions 5 through 16, and here's all the answers. Actually, the only one that I have to change here is right here. This is plus or minus 2i. So let's go ahead and make that note there. So moving on, question 5. Take out a GCF, and then go ahead. We see a trinomial. X to the 4th power is really x squared squared. So it's a trinomial from quadratics. So you go ahead and set it up as binomial times binomial. And then once you get that, notice in blue here we can then set it equal to 0 and solve. Okay? And what we have here is 6x squared minus 1 equals 0. Move the 1 to the other side, and you simply just take the square root. And when you do that, you have plus or minus. You cannot have a radical on the bottom, so that's why you have radical 6 over 6. We'll see how to do this synthetically towards the end. Okay? So pulling out those things there. Question number 6 is the same thing. Factor as a trinomial. And then notice both of them are squared, and those are difference of squares. So break them down again. Here we have all linear factors. So that's an example of linear factors right there. And our solutions are positive negative 4 and positive negative 2. Question 7, again, is a difference of cubes. Question 9, again, take out GCFs of an x. That is the solution, so it's a 0. And then the rest is a quadratic that you can factor. Question 9, notice when I take out an x squared, what we have here is 2 solutions at 0. So you have 3 answers, 0, 4, negative 2. But since we have x to the 4th power, that 0 happens twice. And we'll see this when it comes to graphing. So I just want to know that we can't account for all 4 solutions. There's actually 2 solutions at 0. We'll see that more in graphing. What we have here now, next one is, again, factoring like a quadratic. And then, again, breaking them down. Now notice here, when we have x squared plus 1, what we have here is x plus 1i and plus I again. Okay. So what happens here is this is a positive 1. And when you take a square root of negative 1, what we're going to have is positive and negative I. Okay. So I'm just going to write this a little better here. So that's negative 1. And then when we take the square root of negative 1, we get I. So notice in this one, if I said factor completely with respect to real numbers, it's this level. If I said factor completely with respect to linear factors, it's going to be this bottom one here. Okay? So we have to know the difference between those two as well. Okay, here, 11, difference of cubes. Okay, What I have up here in green is, a lot of people say, well, can't I just take the cube root? Yes, you can, and you get x equals 1. You only get one answer, but being that it's x cubed, there's really 3 answers here, so you have to account for 2 more solutions. They happen to be imaginary. So what method do we do now? Is difference of cubes. Move the 1 over to the other side. You have x cubed minus 1 equals 0. That's a pattern. Difference of cubes pattern. Go ahead and set it up. Now notice for the difference of cube pattern, a lot of these elements here, underline, can't factor, no clean way, so use the quadratic formula to break down a quadratic. And notice you're going to get an imaginary solution like we have down here. Okay, so let's move this down a little bit. And we have negative 1 plus or minus I radical 3 all over 2. So that's the imaginary set. The real answer is 1 for a total of 3 total solutions. Okay, 12, the grouping problem, and again, solving for x squared plus 5. Okay, so a total of 3 answers. 1 real, 2 imaginary. Okay, imaginaries always comes in pair in regards to polynomials here. Okay, 13, again, factoring, difference of squares. Notice x squared plus 4 is plus or minus 2y. Okay. 14, again, key here is get everything set equal to 0, take out an x, quadratic formula, because it doesn't factor. 15, again, just breaking up into factoring and set them both equal to 0 and taking the square root. 16, the key here is this. A lot of people say, well, can't I just set each parentheses equal to 0? No, because it equals 36. You have to have it equal to 0. So notice, you have to set it equal to 0. So what you have to do is put it into standard form, which means multiply everything out. First I did the first 2 in blue, and then I did the third parenthesis in green. And then at the end, I added on negative 4 minus 36. Then from here, from this step right here, I'll put a box around it. That is standard form right there. From that step, then you say, hey, 4 terms, let's group it, and you find out we can factor it into 2 pieces right there. And then you can get your solution. So it's almost like completing the square, but here we're completing the cube. Okay, similar type of concept. Okay, what I want to move on to now is solving using synthetic division. So what we're going to do is look at problem 13. Now again, looking back at it, notice we have positive negative 4 and positive negative 2y. And we solved it by factoring. I'm going to show you how to do it synthetic division. Let's say you didn't pick up on the factoring portion. So what I did was first I entered it into my calculator. Okay, so I enter it in as you see there. And then I go ahead and hit graph. And notice I have a couple different solutions. This is in standard view, so every tick is 1. So here I have, it appears to be at negative 4 comma 0, a solution, and here at positive 4 comma 0. Now, again, we're not zoomed in real well, so how do we test to see if that is a solution? Synthetic division. So again, I'm going to put it into standard form, and then I'm going to take it on the coefficients. Now notice, 1 for x to the 4th, x cubed is 0, x squared is negative 12, x is 0, and then negative 64 for a constant. So I counted for every degree. I'm going to test negative 4. Bring down to 1, multiply, add them up. Okay, bring it down here, add those up, negative 16. And if you multiply those together, you get 64. And notice when you add, you get 0. So what that tells us is that this is a solution. Okay, because we have 0. Now I'm going to go ahead and test positive 4, because I could see that on my graph. It appears we have a solution 4. So how do I test it? Synthetic division. I want to do this because we don't know if it's 4 or like 4.1 or somewhere near there. So it's some like funky radical or an odd fraction or a decimal. So I'm testing it. So again, I use synthetic division. Notice I pick up where I left it off. I didn't have to go back to the original problem. 4 times 1 is 4. Add them together. And notice it goes down to 0 again. Now, according to my graph, it appears I have all the real zeros. So I have a solution here again at negative 4 and positive 4. So what do I do with the remainder? Now I look at it. Okay, this is my constant. This is my remainder of 0. So this is really translate to 1x squared plus 4. And we say, okay, we have a quadratic now. Very easy to deal with. So how do we solve a quadratic? you set it equal to 0, and we simply say x squared plus 4 is equal to 0, x squared is equal to negative 4, x is equal to plus or minus 2y. And notice we're able to count to two solutions there, a solution here and a solution here, and we have our four solutions of negative 4, positive 4, plus or minus 2y. So notice I used my McGaughran calculator to get me started, synthetic division to clean it up, and check my answers. I'm going to do one more example. So this is question number 5. So let's go ahead and take a look at what 5 looked like on factoring. Okay. All right, so notice here I had to take out GCF, factor it, and I got plus or minus radical 6 over 6, a very nasty number, and plus or minus 1. So notice we have 4 real answers. So you're going to see all 4 appear. So looking at my calculator, I first plugged it in. And when I hit graph, it was hard to see because I had 4 solutions very tight. So I went ahead and changed my window. And I put negative 3 and positive 3. So every tick mark here is one thing. So I basically zoomed in on the graph. Now notice, looking at my graph, it appears I have a solution at 1 and at negative 1. But then I have a couple solutions that are in between 0 and 1. And I'm not really sure what they are. Are they 0.5? I'm not sure. And if you recall, the solutions were radical 6 over 6. So how do I get that using synthetic division? Very simply, test the ones that look the simplest, negative 1 and positive 1. Okay? So I'm going to test those two first. So let's go ahead and try that. Again, I'm going to set it up. 18 is my x to the 4th, 0x cubed, negative 21x squared, 0 x's, and 3 for my constant. I'm going to go ahead and test negative 1. The order you test them doesn't matter. I could easily start with positive 1. Okay, bring down 18, add them together. And notice we have a solution because we have a remainder of 0. Okay, so I'm going to go ahead and test now positive 1. And we have a solution once again. Now notice how quickly I can go through synthetic division. So once you get in a calculator, very easy to test it. Now, I still have 2 more things, but I'm not sure what they are. So I'm going to go ahead and take my numbers and translate it back to a polynomial. And what you have here is 18x squared minus 3 is equal to 0. Now that it's a quadratic, very easy for me just to take the square root. So I'm going to say 18x squared equals 3. X squared equals 3 divided by 18. Cross that out, change it to 1/6, and say, all right, what do I do now? Take the square root, and very simply, x equals plus or minus the square root of 1 over the square root of 6. We know we have to rationalize it, i.e. plus or minus the square root of 6 over 6. 2 solutions there, both real, solutions at positive and negative 1 as well. So that is another method of how to solve these things using your calculator and synthetic division. Okay? So I just want to throw that out there. This is a good lecture to look over as far as different ways to solve polynomials.